Hello everyone. So today we are going to cover number of 1 bits, otherwise known as Hamming weight. So we are given an input of an integer n with zeros and ones, and we have to return how many ones are there in the given number. It's pretty simple. So let's discuss the solutions. Here is our input. If you see, it is a 32-bit integer. So we have to check how many ones the integer has. So if you manually count, it is having 3 ones and the output is 3. So we here are going to discuss two different solutions for the same problem. The first solution is going to be, our first solution is pretty straightforward. That is, we're going to start from the rightmost bit of the given number and check whether it is 1 or not. If it is a 1, then count and move to the second number. So how are we going to do that? So first, performing AND operation. We are going to understand the functionality of these two things, and with the help of that we are going to do our algorithm. So first thing is performing AND. What would AND do? So basically the operations of AND are, if it is a 0 and 0, it is going to be 0. If it is 0 and 1, it is going to be 0 again. If it is a 1 and 0, it is going to be 0 again, and 1 and 1 will only give 1. So we are going to perform AND operation with 1 to every bit of the number here. So it will return 1 if the bit is a 1. So then the answer will be counted. If not, it is a 0. We don't have to count the answer or the counter we have. So pretty simple, right? So what is the purpose of right shift operation here? So right shift operation will actually shift the rightmost element from the given number. For example, if this is the given number, performing a right shift will make the number 110, and 110, after doing a right shift, it will become 11, and again it will become 1, and finally it will become 0. So every time we perform a right shift operation, it is going to take away the rightmost bit and end with the previous number. So every time we're going to check our rightmost bit is a 1 or not by performing an AND. If it is a 1, then we are going to increment our answer and then shift that number and go for the next rightmost bit. So pretty straightforward algorithm. It is going to be like this. That is performing an and if it is equal to 1, then count and then do a right shift. So this algorithm is very simple, but this will work only if the given bit is a 32-bit integer. That is, if our number is having maximum of 32 ones, then this solution will work. If it goes beyond even a single digit, it is going to give us 0 as our answer. So in that case, we have to simplify the same algorithm a bit more different to achieve our goal. So how to do that? Let's go to the solution 2. Solution 2 is clearing the least significant bit. Let's see manually how does it work. So if you see, if 1101 is the given number, if you clear the least significant bit, that is here the least significant one is here. If you clear that, it will become 1100. Here the least significant bit is this, and now if you take away that bit, it will become 1000, and finally here if you take the least significant bit, it will become 0000. So how many transformations it took? If you see from this number, it has took 3 transformations to finally end up with removing all ones and become all zeros. So our answer is 3. That is, it took 3 steps to remove 1 each time. So finally we removed all our ones in 3 steps, which means we had 3 ones in our integer. So how do we actually remove this in our code? We manually did it very simple, but how do we instruct the system to do this? To perform that, we have an option of number and number minus 1. That is, consider the number 1101. the previous number, that is n minus 1, is going to be 1100. So perform an AND. As I said, if it is a 1 1, then it will be a 1 1, otherwise it is a 0. The number becomes 1100. So the previous number to 1100 is 1011. Perform an and it will become 1000. So finally, the previous number to 1000 is 0111. And perform an it will become all zeros. By that, every time we make it to the previous number, we remove the one least significant one, increment your answer. Finally, when it becomes 0, the loop terminates and we have to return this answer. So the solution is going to be pretty simple again. Let's code it. As we discussed the examples, let's directly code it. As I said, I'm going to loop it until the number is not is equal to 0. So I'm declaring a variable answer and I'm going to return it. In between, I'm going to increment answer. It entered loop because it had ones. So in that case, before taking away that one, I'm taking it as the count to our answer and then take it away. So to do that, let's run. So I have passed a 32-bit integer. So let's submit. Yes. Thanks for watching the video. Thank you.